Hi. How are
Hello.
you?
Hi, Sonia.
Hi.
Hi, Sonia.
Everything good on your side?
Everything is fine, as always.
Everything as always. I just
Okay.
wanted to pop in and make sure you all are good to go.
Okay, Sonia, for your information, I already
Uh-huh.
started the webinar.
Oh, that's
Because-
okay. That's
Yes,
fine.
Okay.
It happens. That's okay. We'll trim it afterwards. But at the time, then you'll have participants come in and you go ahead and you start. But so good to see you all.
Yes.
I am gonna jump back out because I have somebody that needs some support on my side. So thank you all, and I will talk to you all soon. Bye.
Okay, now, bye. Okay.
Click F5 to see the presentation without the notes.
Okay.
You see the notes? No.
Actually,
what do you see, guys? Because you are supposed to see the presentation only.
Yes, we only see the presentation. That's correct.
let me check.
Now they head screen, so nothing else. You should see only the head screen. Is it so?
Okay.
What can you see, Tomas, now?
Just a second. I see it also with notes. I don't know why. Can you move? Can you move the slide?
Yeah, I can, sure. Now it's the second slide, third slide.
Which actually I don't see. I don't see the slides.
So
you are viewing Wojciech Majka's screen, but
and Queen Gao, you do you see it? We can't hear you now. I can't hear you. You have the muted phone speaker.
Yes, sorry. Yes, indeed. I was just talking to my colleague.
And
so, here comes my boss. See what to.
You should see the first slide. I mean, the LRVS logo and our names on it. Can you see it?
Yeah, I see the full page.
The full page, yeah. That's
Yes.
what you should see.
Yes.
And now the second slide,
already.
third slide. But Tomas, can you see it?
But I really see the presentation open on the first slide, but also other slides and also the notes. And if you move the slide, I don't see.
But are you sure you see my screen, or maybe you have opened your screen somehow?
No,
I mean, your presentation in it.
It's everything is closed, and I have here information. You are viewing Wojciech Majka screen.
Correct. We're viewing. Yeah, Majka, we're viewing your screen.
But because Tomas don't see changes, and when I click to the next slide, you can see it, Queen. Yeah. You see the presentation agenda now or not?
No, I do not see anything. Can you change to the presentation mode?
Yeah, I did.
Show the slide.
I already did. That's the problem. Give me a second.
I see now the camera.
I will share it again.
Try it.
Na który? Jesteś pewna, że to?
Maybe I should stop.
Okay.
We see the screen and the pointer.
Okay. I'm clicking to present. Give me a second. It was supposed to work. Check it out.
We still see the PowerPoint with the details, but not full screen of the presentation.
Yeah, we can see it too. It's not entering the presentation mode for some reason. Wait, give us a second. It's always some problems. I will stop sharing in one more time. Okay, you see the presentation. That I'm sure, but when I click present, it does not work. And now you can see it?
Yes.
Yeah.
Yes.
Working.
Okay,
good.
I had some
Perfect.
conflict with my screens. So I'm sorry.
Yes.
For that.
No
Okay.
problem. Go
We
ahead.
need to starting. Hi, hello everybody. Sorry for just we had some technical issues. Well, welcome to the session. My name is Qing. I'm the inside sales from the FreeTech Europe team, and today we have two gentlemen here with us. Mr. Wojciech and Majka. He's the president and the CEO of the Ecol. And then the other gentleman is Mr. Tomas Klima, and he is the head of international sales division at Ecol. And today they're going to give us some inside information about high velocity oil flush with comprehensive cleaning, the keys to reliable oil system operation with Ecol Care. Here you go.
Hello, everybody. Thank you. My name is Majka, and my co-speaker, Tomas. We are at your service. Yeah, today we'd like to share some thoughts about the oil flushing and some cleaning methods for the turbine oil systems. Thank you so much, the organizers, to let us speak and having us invited. The agenda for the presentation is as follows. So short introduction. So what do we do at Ecol Group? The problem of dirty oil systems, then some basics of our technology of intensive hydrodynamic cleaning for the oil systems purposes. Then some words about high velocity oil flushing, some summary, of course, and question and answers agenda. So our service portfolio, just to give you the picture who we are the company providing outsourcing of maintenance in area of lubrication management. From the very beginning, from idea, techniques, supporting services, labor, everything. So one of the parts of these activities used to be preparation of oil systems, especially for turbines, large equipment. So the cleaning and flushing of oil system became one of the key services that we are providing. In the meanwhile, of course, there are some other techniques for cleaning, some chemical services for turbines, for power generation equipment, oil analysis laboratory. Just behind me, there is a lab where I'm in now, doing oil analysis in diagnostic programs for the lubrication and tribology. Short lubricant supply, so everything that deals with supplies regarding the maintenance plants in the lubrication area, and some other techniques for activities in industry. We are based in Poland, where I am now. We have subsidiaries in Czech Republic, where Tomas is now in Czech Republic near Prague, in Vlašim city, and the other part of us is located in North America, in Florida, which we do some services around that area in Americas technically. We are process-driven company, so standards are not odd for us. We have ISO's standards in place, including certification for the lab, which is accreditation technically. We are following the requirements of ICML 55.1 standard, meaning the lubricated asset management standards, and we are trying to provide reliability services to our customers, especially in the area of lubrication management and whatever is common with the tribology. The size of the company, we are 400 people on board, even more, I would say 420 probably now in these 3 locations. We are providing around 500,000 lubrication and maintenance tasks every year, which is pretty substantial. The size of the lab does around 45,000 samples every year, and it's been done within last 30 years of our history. Tomas, I'm not sure how long have you been here with us?
Well, Thank you, Wojciech, for the word. Thank you, the audience. Hello, everybody. I'm actually 18 years with you, Wojciech, which is a long time where I definitely gained a lot of experiences, as well as others in Ecol, as well as you. And this is what we are doing so many years. As you can see, within this time, we did clean and flushed over 850 turbo units, different kind, different sizes, complexity, different environment. I mean, industries. The largest we did is the over 1,000 megawatts turbines from nuclear power plants. Not only one, several of them in different countries. And we are servicing different OEMs, directly or indirectly. And we started to be the service partner for them with the issue of contaminated oil system, which is actually contamination and cleanliness plays the key role in machinery operation, as impacting very much and very effective the production of the plant, where however, oil care seems to be recognized as very good maintenance service, condition monitoring very well developed nowadays. However, as we see from on site, from our customers and projects, that the purity of oil system itself is still underestimated. You can see that degradation comes to the system either from the environment directly or indirectly, from the environment as a dust, or indirectly during the maintenance by assembling and disassembling the equipment that is in the oil system. Of course, also from degradation or corrosion process. Degradation here will be also mentioned, especially varnish and others. And everything is accumulating and settling down in the system, circulating and agglomerating. However, the degradation is something for Wojciech that is introducing to
yeah, that's the key element of every operation of the lubricants, both just mineral or hydrocarbon based lubricants, but also the ester based fluids, which are pretty popular in some areas like control systems or lubrication systems for nuclear turbines, or maybe in some high power hydraulics in steelworks. Anyway, both types of lubricants do age. Somehow they are changing the properties. They are generating lots of byproducts, which is aging products related to oxidation, thermal stress, some reactions also with the environment, with elements of the oil system. Many times cross-contamination becomes a problem when somebody accidentally or maybe on purpose do mix lubricants. Everything of that creates potential for sludging, for creating varnish, for creating different kind of deposits that most of the time accumulate over the time. And if the user does not mitigate them somehow properly over the time, there's a moment where these deposits take control over the cleanliness of the system and become a real problem in operations. Which areas are in danger? Of course, bearings. That's a very common situation with varnish, with deposits. Also mechanical impurities. We have control systems, hydraulic pumps, valves, all the elements that working with very precise fittings. Hydrogen-cooled generator seals, also in the compressors. Seals of the compressors are prone to have some issues with the cleanliness and deposits formations. And of course, transmission gearboxes are the subject of problems in this case. Tomas, tell us something about the real case that we see it.
Yeah, following up the theory you said to us, we see now the reality what we are witnessing by the customer on many projects. As you can see in the middle top, a typical varnish issue on stainless steel pipe, so very well visible. The same on the right top, combined with corrosion on the black steel. Or other pictures, collected sludge in the oil tank, oil reservoirs. This is the reality what we are witnessing by the customer. There are other examples. As you can see, the oil coolers, very heavily deposited oil coolers, which is definitely causing a problem, operational problem to the customer. Sometimes the problems are not only temperature or cleanliness, but also resulting in seizure of the components like bearing, pump components. As you can see in the middle down, the really debris going out from the bearing. So something definitely happening here.
Yeah, it also is a problem for the new systems. Although we are talking about the operated systems, but for new builds, prior to commissioning, we are facing a lot of deposits as well. So rust, some protective coatings, some paint, different post-production and post-assembly impurities. And that is also the subject of thorough cleaning prior to the first commissioning. And you must know that sometimes the first commissioning, first startup is the only startup before another repair. That's why we are taking care so much care of cleanliness of the system itself, not only oil, because dirty system will be emitting deposits and debris in the future. So what's the solution? Just a short overview. First approach, we can clean the system. Our cleaning technology that we are providing and trying to apply for this very dirty system is the high pressure water cleaning. We call it hydroblasting, in order to remove deposits and any impurities. So remove, clean, detach from the surface and remove with water. Then there is another step, the next step, which is crucial for this fine filtration of the oil, which is very high flow rate oil flushing. So you know, high flow oil flush to get these turbulent flows and turbulent environment in the pipes. And of course, when it's done, post-assembly filtration to have the system really fine and ready for the operation without any troubles. You may see these different requirements and technologies that are supported or required by different OEMs, different standards like VGB standards, of course ASTM, the recent one, the 6439, which is discussing different technologies of cleaning, not only this one. We are presenting also another approaches that are useful for preparing the oil system.
Yeah, following up the process, the first phase, what we want to do is to clean the system, to getting rid of the deposits, which is based on high pressure water cleaning or hydrojetting, as you like, where the process is that hydro jets are penetrating and removing all the deposits from the inner surfaces of pipes, from inner surfaces of other components, and following cleaning, there is a phase called drying, where we are willing and are drying the system with compressed air to get rid of the water. And after that, when we speak of non-stainless steel pipes, we need to protect it for the time when flushing comes. You can see it also on the pictures, how it looks like on site. You can see visibly the nozzles with the water jets. These water jets are penetrating all the deposits, hard deposits, soft deposit, varnish and others. And you can see on the top in the middle, the worker that is introducing the nozzle into the pipes. And one by one, the pipeline is cleaned with this technology. You can see on the right hand, the process from distance, where there is the operator of the nozzle, as well as the co-worker that is operating the pressure valve. helping him in the process. And also you see some details how the site is prepared and the cleanliness is maintained. Of course, the components of the oil system needs to be also cleaned. As you can see on the right, there is a special basin where we clean the components like valves, short pipes, oil coolers, and other elements. Or we can do it in our workshop with automated cleaning, like you see the automatic cleaning of that cooler. Yeah, so the results, this is the main important topic for the customer to see what is the result after the cleaning. You can see very well on the middle picture, the stainless steel before and after cleaning. So completely out of deposits like varnish that was heavily varnished system in the oil and gas plant. You see also other pictures where the corrosion and heavy asphalt deposits, I would call it, are removed completely, and also the corrosion. So the effect is visible and proven to the customer, which is very important.
Yeah, that's very important that when we clean the system, to protect the system after the cleaning. So when it's dried and it's protected against the corrosion itself, we need to get rid of any external impurities that can get inside after the cleaning, and which is also important to make sure that you can assemble the system altogether correctly. So these foreign material inclusion systems or procedures are in place, also properly marking and protecting all the system which was disassembled for any purpose in this case. Sure, there is a quality support, which means endoscopy and evaluation of the cleanliness of the surfaces. There's a plan of hydroblasting, inspections, of course, documentation for the customer and for the future, that everything was correctly prepared for flushing. And now the flushing comes in. The system was clean already, but it has some loose contamination in it inside. So now we want to make sure that this contamination will get removed by the oil itself. So we are flushing the system.
There are common approaches, standard or conventional, which is not always the same. Every OEM has little differences in it. However, the idea is to employ the system pumps to change the oil, put the new one, flush it with the system pump. However, this is not very sufficient because the pump is designed for delivering the oil into the bearing on a certain pressure, on a certain amount. However, this is producing only a laminar flow, which is not effective enough in the long term. And we, on the other hand, are employing technology, which is the point 2 of our technology, high velocity oil flush, or turbulent flushing, as you wish, which is based on high velocity oil pump, creating large velocities of the oil, special designed full flow filters that are also the key element of reaching the cleanliness, high cleanliness during the flushing. And also set of bypasses installed on components like bearing, servo valves, pumps, and others. And there is also specific component that we are using for having a control over the process are special design control filters with a very strong magnet. You will see later some pictures on it. And the technology also combines some parts, control filters I already mentioned. All jumpers are equipped with valves in order to be able to handle with the flow during specific pipelines. So not everything open and letting just having laminar stream into the system, but we are changing from one pipe to another according to engineering study, engineering preparation, where also such schematics is prepared for us, for the team that is realizing, as well as for the customer to giving him understanding how we will do the flushing, and he will confirm. So you see on the schematics our pumps, our filters, our jumpers, control filters on the bearings, and so on. Other things are also taking into account, but this is the word for Wojciech.
Yeah, so this is about planning, scheduling every task from the safety quality perspective and feasibility study. So it takes a lot of logistics of hoses, manifolds, valves, pumps, temporary tanks, all that which is required and which is designed for application. It's also about supplying the lubricants for flushing, whether these are for in the barrels or drums, whether this is some bulk supplies in cisterns. Everything has to be done properly because our activities, cleaning and flushing, takes some time, and we want to be as much as consistent and reliable in these operations, especially when we are handling with something which is at the end flammable, like a fluid, oil fluids, and also dangerous for the environment and for the safety. So you can see a lot of hoses, lots of confined space filled up with this equipment. Temporary, however, but it's also kind of challenging, while the overhaul, the general overhaul of the machine is ongoing as well. So that's why we need to know how to fit this specific situation. Quality control of the flushing is a key. So we want to know how quickly we are improving with the cleanliness, what kind of impurities are still in the system, and what's the change of them. That's why we are using this control filters that Tomas mentioned. We are using them with kind of magnetic rods, magnetic traps, which are showing us if any metallic debris is there or not, and kind of plastic strainers that we can also control what kind of impurities and what rate they change over the time of flushing. Of course, classic methods like evaluation of the cleanliness, which is particle monitors or particle counters, also in use to make everything as much objective as we can do. So we are using, from our perspective, mostly blockage cleanliness monitors, because laser based monitors for flushing are very sensitive to bubbles, which we have a lot in the oil. That's why we rather use microscope methods or these blockage systems. So at the end, when we do the flush, we end it, the turbine or the machinery is getting assembled together to the original configuration, is ready for the operation. And then when everything is assembled, we just do the final stage, which is offline refiltration, meaning the polishing the oil quality to the accepted level that we can really say green light or go for the operation. So technically that is how the whole process looks like.
Thank you, Wojciech. Everything was said probably. Let me summarizing that. I would definitely like to say that this technology is proven technology with visible effect, visible for the customer, completely developed and on many projects experienced and confirmed. The hydroblasting itself is very much shortening the future flushing process, which is for us also the guarantee that we can give to the customer the timeline. We can guarantee the timeline if we do the hydroblasting first prior to the flushing, and this means also start up on time.
Yeah, and this is also making the system very clean prior we use the lubricants. So we are sure that there is no impact of any deposits or any previous lubricants for the new lubricant. That is also a saving for the customer. And in this case, we are also do not use any flushing batches of oil, which is substantial saving. And this is really eco-friendly, reducing waste, reducing time, of course, energy, and other parts of this being sustainable approach. It's also saving some problems with interpretation of oil analysis reports, because since we have zero or baseline condition of the clean system, we can have better diagnostics and trend monitoring in the future. So we really believe that in some cases, not all of them, but some cases require such deep cleaning. And sometimes, which is also important, you do not have to change your system. You just can restore it by thorough cleaning and maybe some small upgrade and continue with the operation, which is really significant nowadays. So thank you for your part, Tomas. Thank you all the audience for your time, and we are open for questions. Thank you.
We already have 3 questions popping up. Are you able to see them from your screen? The Q&A.
Yeah, I opened the Q&A. Tomas, can you see it? Because I'm not sure if
I see it. Does high velocity oil flush demand an intermediate fluid to remove debris, or new oil can be inserted directly after a high velocity oil flush? Actually, after the hydroblasting process, the first cleaning process, we can already use the final oil that will be in operation without any harm, without any change of quality and chemical parameters. So we are sure that no residues that can be chemically affecting the oil, the new oil, are remaining.
Yeah. I'll take the next question. What is the Reynolds coefficient you choose for your high velocity oil flush operations? Basically, we're trying to have it more than 4,000. That usually should be enough. Of course, in very large diameters, sometimes return lines are very big, like even almost 1 meter in diameter. So it's in these cases it's very difficult to achieve very high flow rates. That is why we so thoroughly clean the system to make sure there is no impurities. But our principle is to make sure 4,000 and above, but also changing the flow directions sometimes, so we can control flow and also disturbing these flows. So it's not only continuous flow at some Reynolds, but also distortions in the flows.
But let me comment it, Wojciech. Besides that, even for the return lines, as you are saying, it's large diameter. We are anyway during the process of flushing preparation, we are building a new pipe, actually extra pipe that is delivering the oil into the return lines. It was visible on the photographs, however, not commented well during the shortage of time. But this is not only jumpers from delivery from the delivery line to the return line. We also built a special additional hose. As you see, the diameter. This is 200 centimeters diameter hose, which is distributed to every bearing. So every return line is additionally filled with oil to be able to flush it properly, not laminary.
Mm-hmm. Yeah, and the third question is, thank you for a great presentation. One question that popped up is, how do you deal with the wastewater and solids that is cleaned out? Secondly, what's the normal timeline for a cleaning operation? Wastewater in a situation when we are cleaning hydrocarbon oils, so mineral or even synthetic PAOs, it's not an issue because it can be easily separated. We are using water separators that we can get rid of the oily part from the water, and the water can go to industrial sewage that you have in any plant. So we are making sure that wastewater is meeting the requirements of the sewage system of the plant. If no, of course, we can take it and dispose it into wastewater treatment plant if required. So it's not going to environment. We are condensing the oily part and disposing it surely accordingly to the requirements. The same with the solids. The solids like rust or the heavy deposits, they sediment on the bottom of our collection tanks. That's again the same. We are removing the sludge from our temporary tanks for wastewater and disposing them accordingly to requirements. So it's not a big deal. Comparing to chemical methods that you are using some chemicals for pickling or so, we have no such waste in this case. And the about timeline, that depends on many factors. That depends on one thing, how much time we have, meaning whether we should work or we can work one shift a day or both shifts, 24 hours a day, how large is the system, how was the condition of the system, etc. However, for a large system like maybe a large turbine of 400 megawatts, if you had 9 bearings in the system, and the system of capacity maybe 50,000 liters, the whole procedure, if it was working 24 hours a day, that could take around 20 days. So it's on one hand, it's short because it's a lot of things to be done, but on the other hand, that time is a little bit long. However, the question, if we can fit the overhaul schedule, yes, we can. We are not stopping other activity on the turbine deck in the overhaul. That is why we can work really in the between of any other activities, and we can really fit the deadline of the overhaul. It can be shorter sometimes, but if the customer has more time, it can be also longer. Depends on many conditions. Tomas, maybe you can comment it.
Let me comment it. Where there is a need, we can do really fast, employing more people, which is demanding for us, definitely. On the other hand, for example, nuclear power plant, during the fuel change, they don't stop for a long time, and we will manage it within the fuel change, because we are starting just at the moment where the turbine is out of rotation and the oil is not needed for the machine, and doing everything during the overhaul parallelly to the OEM or to the service partner, service company. So this is, and we can do also more machines at the same time. We have had many projects where we did 2 turbines parallelly, 2 teams. So we are equipped for that.
Sorry for me to jump in. First of all, thanks, Mr. Majka and Mr. Klima for this great presentation, but I'm sorry to remind everyone, the time is up. Unfortunately, we'll have to end up the session soon. What the thing is, if you have any more questions, you can contact Mr. Majka and Mr. Klima directly, and they have left their contact information on the screen just a few seconds ago. So once again, thanks everybody for joining, and thanks again to the gentlemen for this fantastic presentation. I wish everybody still a very nice day. So bye-bye, everyone.
Thank you. It will be a pleasure to get in contact with you. Thank you.
Thank you very much. Thank you, Tomas, for joining us.
Thank you, Wojciech,
today.
for
Okay.
Thank
Bye.
You. Goodbye.